I will be showing you how to work exercise 2.31. So part A of this exercise asks you to find the instantaneous acceleration at t equals 3 seconds. And from the graph right here, you're able to tell that the acceleration is 0 meters per second squared because the line was parallel to the x-axis. In part B, we are asked to find the instantaneous acceleration at t equals 7 seconds, which we take the initial velocity, subtract the initial velocity from the final velocity, as well as the initial time from the final time, to equal 6.25 meters per second squared. And then we go to part C where it's asking for the instantaneous acceleration at t equals 11 seconds, which you can see here. I worked it out the same way I worked out B, just had to change the values, which would amount to negative 11.25 meters per second squared. And then in part D, it asks how far does the officer go in the first 5 seconds. And from that, we can calculate distance equals, from the equation, distance equals velocity times time, which we would get 100 meters. And then part E asks how far the officer goes in the first 9 seconds, which makes this a little bit trickier in this problem, because now in order to figure that out, we take the area of this section in order to figure that out, which I've done so here. I figured out the area of a rectangle that is underneath the graph, which equals 180, and then the triangle that also is underneath the allotted time interval, which amounts to 230 meters. And then in part F, we were asked how far the officer goes in the first 13 seconds. So we do the same thing we did earlier, except now we include this other section of the triangle. And in doing so, we end up with 320 meters. And that concludes 2.31.